Exercise 2, second session 2022 LS. Motion of a hockey puck. The purpose of this exercise is to study the motion of a hockey puck M. M, taken as a particle of mass m equals 170 grams, can slide on a horizontal ice rink. A hockey player hits puck M with his stick form at point A. Take the horizontal plane passing through M as a reference level for the gravitational potential energy. 1. The collision between M and the stick occurs in a very short time. Choose the correct sentence out of the three following sentences. عندي ثلاثة. شو hits a puck M. Sentence 1. During this collision, the linear momentum and the kinetic energy of the system stick M are necessarily conserved. يعني عم بيقول لي بأول statement during collision لازم تكون linear momentum kinetic energy اتنيناتهم conserved. Sentence 2. During this collision, the linear momentum of the system is conserved but the kinetic energy is not necessarily conserved. Statement ثالثة. During this collision, the linear momentum is not necessarily conserved but the kinetic energy of the system is necessarily conserved. مثل ما شايفين هون عندنا situation اللي هي اسمها collision وعندنا two physical quantities عم يحكي عن conservation لإلهم. conserved يعني constant, it stays or it remains constant. The first quantity is linear momentum, the second quantity is kinetic energy. يعني عندنا ال P and KE. نحن لازم نكون عارفين على طول regarding the type of collision. During a collision the system can be considered isolated وكمان لأنه التايم very short على طول collision يعني linear momentum is conserved. هلا لازم نكون عارفين انه لحتى kinetic energy تكون conserved بده يكون collision is perfectly elastic collision. يعني collision لازم تكونوا عارفين collision يعني linear momentum is conserved. Moreover, if the collision is elastic يعني kinetic energy is conserved. فهون أكيد sentence 2 هي correct. طالما عنا during collision the linear momentum is conserved وهون عم بيقول لي not necessarily conserved فstatement 3 غلط وstatement 1 غلط لأنه عم بيقول لي kinetic energy necessarily conserved. أكيد لا، ممكن تكون linear momentum لأنه collision conserved بس kinetic energy لأنه not elastic collision not conserved. فstatement 2 is correct. Now, just after the collision, M is launched from point A with a velocity moves on x-axis, it stops at B. AB equal 54 during delta T. عم بيقول لي calculate the mechanical energy of the system M Earth at point A and then at B. هلا نحن بنعرف انه الميكانيكال انرجي هي sum of kinetic and potential energies. هون بهذا السؤال ما في spring، ما في داعي اجيب سيرة elastic potential energy فبكتفي بالpotential اللي هي just gravitational potential energy. Now we have two positions. In order to determine the mechanical energy at a given position we need the speed and the height. هو قال لي M the horizontal plane passing through M is taken as a reference level. Mechanical energy at A هي kinetic at A plus GPE at A. kinetic at A half mv squared plus mgh. VA 18 given HA 0 since A is on the reference level therefore the energy is totally kinetic فاللي هي بتطلع 27.54. ما بنسى اعمل conversion الماس 170 grams بتصير 0.17 kilograms. We divide by 1000 or we multiply by 10 power negative 3. كمان in order to determine the mechanical energy at a given position we need the speed of M at this position and the height at this position. At B كمان B is on the reference level, no height no GPE. وقال لي بالسؤال انه it stops at B. على طول كلمة stop معناتها V equals 0. Therefore the mechanical energy at B is 0. No gravitational potential energy since there is no height, no kinetic energy لأنه no speed فالmechanical energy 0. وهون ال justification GPE A equal GPE B 0 on reference. Kinetic at B 0 لأنه ال VB 0. Now deduce that M is submitted to a force of friction. أكيد mechanical energy at A is 27.54, mechanical energy at B is 0. The mechanical energy is not constant. فينا نقول إنه mechanical B smaller than mechanical A, or mechanical B does not equal to mechanical A. The mechanical energy is not conserved, يعني constant, therefore M is submitted to a force of friction. Given that F is constant, deduce. هلا معنى ال initial mechanical energy اللي هي at A 27.54 معنى ال final mechanical energy, and the distance is given. فبنشتغل delta mechanical energy equal work done by friction. كيف بطبقها بين A and B؟ ال A ال initial position, ال B ال final position. mechanical final minus mechanical initial اللي هي delta mechanical energy، يعني بدي اقول هون mechanical بالاخير B minus mechanical بالاول A equals to minus F times friction. Mechanical B minus mechanical A equal minus F times times distance. Mechanical B 0, mechanical A 27.54 with distance AB 54 بيطلع ال F 0.51 newtons. Now name the external forces acting on M, draw them on a diagram. M is moving from A to B. هاي البوينت اسمها A to B. The forces acting on M are normal reaction of a support, weight vertically downward, normal reaction of a support perpendicular to the ice ring, and friction opposes motion. Show that the sum of these forces is sigma F equal minus 0.51. Now sigma F external, it represents the sum of all external forces acting on M. Sigma F equals to weight mg plus n plus F. M is moving along the x-axis, there is no motion along y-axis, therefore the vertical forces are balanced. فالmg plus n السم لإلهم زيرو. انتبهوا هون بس بدكم تشتغلوا سيجما اف وتطلعوا السم للفورسز. أول شغلة ما بتشيليهم هيك هاي زيرو هاي زيرو، هني منن زيرو، السم لإلهم زيرو، فالويت بلس ان زيرو فبيبقى عنا الاف. نحن مطلعين الماجنتيود للاف 0.51. ليش حطينا يونت فيكتور اي؟ لانه نحن عم نشتغل along x axis. وليش حطينا ماينس؟ لانه friction opposes motion، يعني opposite للاكس axis يعني opposite to I. therefore الفريكشن هي السيجما اف اللي هي ذاتها الفريكشن هي minus 0.51 I. Now determine the linear momenta PA and PB at A and B respectively. هون بس بدي اعمل apply للرول. We know that the linear momentum is equal to the mass multiplied by the velocity. Therefore the linear momentum at A is mass times the velocity at A. mass 0.17, velocity is 18 I. We get PA 3.06 I. Similarly PB equals to MVB. The M stops at B, يعني ال V0, therefore P equals to 0. Deduce the variation delta P of the linear momentum. Delta P equal P final minus P initial, يعني delta P equal PB minus PA. PB 0 minus 3.06, we get minus 3.06. Now calculate delta T knowing that delta P equals sigma F delta T. Delta T equals to delta P over delta sigma F. فينا نحط norm. delta P طلعناها ببارت 2.7 طلعت minus 3.06، والسيجما F معنا إياها ببارت 2.5 minus 0.51. therefore we get delta T equals 6 seconds.